we're going to start section 5.6, which is about defining sequences recursively. So to start with, let's remind ourselves, we talked previously about sequences. So sequences, remember, they're an ordered list of numbers. So now let's define a recurrence relation. A recurrence relation for a sequence A0, A1, A2, and so forth is a formula that relates each term called AK to a certain number of its predecessors. So basically, AK is defined in terms of the terms that come before it. So let's look at an example. Let's define a sequence C0, C1, C2 recursively as follows. So I'm going to say for every integer k greater than or equal to 2, ck will be ck minus 1 plus k ck minus 2 plus 1. And then I'm going to tell you C0 is 1 and C1 is 2. So these bottom two right here, these are called the initial conditions. And this equation right here, this is your recurrence relation. So the kth term right here is defined in terms of the two terms that come before it. Okay. So let's find, for this problem, let's find C2, C3, and C4. So let's start with C2. And what we're going to use is we're going to use our recurrence relation up here. Let's plug in 2 for k. So if I plug in 2 for k, I'll get C2 is C1 plus 2 C0 plus 1. Well, I know C1 and I know C0 because those were my initial conditions. So I'm going to plug them in to find C2. 2 plus 2 times 1 plus 1. C2 will be 5. All right, and now let's find C3. So again, you're going to go back up to your recurrence relation and plug in k equals 3. So if I plug in k equals 3, it's C3 equals C2 plus 3 C1 plus 1. Again, I know C2, I just found it, and I was given C1 in my initial conditions, so I plug those in. I get C3 is 5 plus 3 times 2 plus 1. C3 will be 12. Okay, we've got one more we need to find. We need to find C4. C4, again, go back to your recurrence relation, plug in k equals 4, and you'll get C4 equals C3 plus 4C2 plus 1. So I need to know C3, which I just found, and I need to know C2, which I also found. So C4 will be 12 plus 4 times 5 plus 1. C4 will be 33.